So what we're going to do now is I'm going to go through the document transformations of functions. If you want to follow along with that, otherwise, I'm just going to explain a little bit about the general transformations of functions. I'm going to use the graph for the function f of x equals x squared. So this is a parabola, opens upward. See the vertex at 0, 0, and some of the points on that graph. And what we're going to do is look at first horizontal transformations. So horizontal expansion and contraction, and shifts horizontally, shifts to the left, shifts to the right. As we can see, now if the function is y equals f of x, if we change the value of a to 2, we see that the graph narrows, or it is compressed toward the y-axis, or the axis of symmetry. It narrows, a horizontal shrink. If we change a to 1/2, we see that the graph gets wider, or a horizontal expansion. The points expand away from the axis of symmetry. If we click in here, show the original, we can see how that's expanded. We change a back to 2, we can see how it's been compressed. Now let's change the parameter a back to 1, and then let's change b. Change b to 2. You see it shifted to the right by 2. If we change it to -2, it's shifted to the left 2. So in both of these cases, nothing about the shape of the graph, the relative size of the graph, the position of the points in relationship to one another, nothing that has not changed. Basically, the entire, I'm going to use this to move things. All I'm doing is taking the entire graph and sliding it left and right. So it's that entire graph just being moved to the left, to the right. So those are the horizontal transformations for parameters a and b. Now if we do 2 at the same time, so for example, if we've got change a to 2 and have b as -3, this would be the graph of 2 x plus 3 squared. 2 x plus 3, and since the function is x squared, it's this whole thing squared. As you can see, it's been shifted to the left 3, and it's been compressed about its axis of symmetry, which now, after the shift, is the line x equals -3. So those are horizontal transformations. So here we are at our interactive figure for the vertical transformations, dealing with parameters c and d, and we'll look at the graph of f of x equals x squared, and we'll look at the parameter c, which is the expansion and compression. So if we change c to 2, we have a vertical expansion. basically the points, if you look at the original, points have been, so this original point has been expanded vertically, this point here expanded vertically, the point 2,4 used to be on the graph, now it's been expanded up here, so the graph is narrowed and it's been vertically expanded. If we make C 1/2, we have a vertical compression. So the 0.11 is moved down here, -1,1 is moved down here. 0.24 was originally on the graph. It's been compressed back toward the line of reference, or the x-axis in this case. So a vertical compression makes the graph wider. And for a negative value of C, we just take -1. This is just a reflection over the x-axis of the original graph. So taking the values of the function, taking their opposites and graphing them. If we take C equals -2, we have the graph narrower and reflected, so the vertical expansion and the reflection. For D, this gives us our vertical translation, or our sliding up and down. So again, the graph shape hasn't changed, the relationship of the points to one another hasn't changed. All that's happening is the entire graph is being slid down or up. Okay, so some different values of D gives us basically the same looking graph, just in a different position. So D doesn't change the scale of the graph, it just moves it up, down. And if we take C -2 and D is 3, this is the graph, which would be -2x squared plus 3. So the function is x squared, -2 times x squared plus 3. The -2 does the vertical expansion, narrows the graph. The negative reflects it, so now it's a downward opening parabola, and the 3 shifts the graph up by 3 units. And now we'll look at changes to all the parameters. So we'll change A, we'll change B, change C, and change D. And from the document, if you happen to be looking at that, we had C equals -3, D equals 1, A equals 2, and B equals 4. So the function we're looking at is -3 times 2, this whole thing, 2x minus 4, that's squared, plus 1. So we have vertical and horizontal expansion, compression, and horizontal and vertical translation, or shifting from left to right, up or down. So A equals 2, that compresses the graph, narrows it, compresses it toward its axis of symmetry. B equals 4, that shifts it to the right by 4 units. C -3, the negative reflects the graph over the x-axis, or its horizontal line of reference. The 3 expands it vertically, narrowing the graph. And D equals 1 shifts the graph up 1 unit. So now we have, if we look at our original, we have a graph which is narrower, it's been expanded vertically, compressed horizontally. It's been reflected, so it's now downward opening parabola. It's been shifted to the right by 4 and up by 4. So as a point of reference, the original vertex was at the origin. Now the vertex has been moved 4 to the right and 1 up. Now the vertex is at 4, 1. Likewise, the axis of symmetry, that has been shifted 4 units to the right. The horizontal line of reference has been shifted up 1, and the graph is narrower. So that, thanks to our interactive figures, is how transformations of functions work.